Hi everyone, this is Chris Mannion with Meander, and on the Recruiting Analytics channel, we're going for a bit of a divergent topic today. I had a question come up a while back when I was sharing some of the work we've been doing on our job board, and I shared one of the approaches that we've taken was to automate away the manual check of whether a job is still active and whether it's been classified the right way. So I actually wanted to do a quick deep dive on how we approach that, share some code. I'm actually going to put the link to the repo in the description so you can actually take the code. It's not going to work exactly because this is actually built on our live app, which is using Django as a backend. But hopefully it will be helpful if you're trying to figure this out for yourself or you just want some ideas about how we've approached this problem. So with that being said, I'm going to jump into automating job board maintenance and show you how we built a bot that's going to automate the active maintenance of the job postings. I'd love to connect with you directly. If you have any questions following up from this, or you're just curious to learn more about what we're doing, check me out on LinkedIn. That's where I'm most active. You can see my URL there, or just search for Chris Mannion and Meander, and hopefully that will come up. So let me talk about the job board as we built it. So what we're trying to do is take the long tail of different job boards from different startups that are newly funded, that are growing, that may not have the visibility on platforms like Indeed, LinkedIn, or even on Google Jobs. So we want to take those and we want to be able to understand exactly what they're looking for and be able to recommend that to job seekers through our platform. So the way that works in practice is we have this data pipeline where we pull in from 200 plus different job boards, the latest job postings. We then run it through a processing process that then helps us to understand exactly how that job is structured, what they're looking for. We load that into our database, and then using a matching algorithm for the user on the front end, we actually help them to figure out what is the right job for them. So that delivers the final matches. So that's great, and that works very well. We have around 100 users on our platform right now. We have around over 1,000 live job postings based on the different jobs that we've pulled in. But we have some problems. So there's three main challenges that any job board is going to face. The first is that job postings may expire or they may get filled. So we've probably all had that experience of seeing a job posting that we really like, clicking on the link and finding that it actually doesn't exist or it's been filled or whatever. So one of the things we want to do is figure out how do we make sure that we don't have a terrible user experience based on the job postings that have already been filled. Secondly, we may find that the job titles can actually mean a range of different things. So just look at software engineering, for instance. You could be a software engineer, a software developer, front-end engineer, back-end engineer, DevOps engineer, just developer, just engineer. And it's very hard to understand at a high level just from the job title what each of those mean. So we're trying to classify based on the job title, what do we believe that role actually entails, and actually how do we pull in the job description to better understand that. And then the third thing is actually figuring out the location. Now, given the different places that you could find job postings, you would want to look for a location that is suitable for you. So I live in Boston, in Massachusetts. So I could see locations for Boston, MA, Boston, Massachusetts, just Boston, Greater Boston area. If you look at the LinkedIn, it could be East Coast, it could be remote US, it could be remote East Coast. So there's all these different classifications that makes sense to the person posting the job. But if you're a job seeker and you're looking at 1,000 different jobs to try and figure out which is the right one for you, it's kind of hard to figure that out. So we approached the auditing process for the different job postings to try and help to minimize those kind of challenges. So the first one, this is actually the easiest to implement. Essentially what we did is build this function that's going to take the job posting. So we collect the URL for the job post for every job post that we pull into our platform, so that people can apply directly. And we create this bot that essentially goes down the list of job postings that are currently active, clicks on the link to see if the link is still active. And so what you're seeing here is the function that we use. It's very short. Essentially, it's try and click on this link and see if you get what's called a 200 response, which means everything's okay. If you don't get a 200 response, then return false. So what this is saying is, no, there's no live job posting at that URL that you gave me. And so at that point, we mark the job as inactive. It's really as simple as that. We're going to test these URLs, and if it's not active, we'll just take it down from our site. Now, note that we don't actually delete the job posting; we just make it inactive. What that means is that we can then track, how long that post has been inactive for, and it actually helps us with some of the additional machine learning work that we do on the back end. But it's helpful to understand that approach. Second step is actually the classification of the job role into a role based on its job title. Now, initially when I started out, I actually built a model, and you're going to see this in the next step, using the GPT prompt engineering. So I would actually train a prompt to try and predict, based on all the different roles that we believe to be the kind of mutually exclusive list of roles, what role does this fall into. And what we do is actually take the whole job description, run it through that process, and then output the role. What I found is that we were only getting about 80% accuracy with that approach. And so what I did instead is start to build this custom machine learning model that actually creates a way for us to estimate the classification of a role based on its job title. So imagine all the different job titles that would equate to a different role. How do we actually build a model? And so there's three parts to this process. The first part, we actually just want to clean the job title. So if you look on different job postings, you'll notice that they can have a range of different kind of commas or hyphens or different punctuation, maybe emojis. We actually want to remove all of that because we just want to look at the core text that's involved in that job title. So once we've got that, we actually turn that job title, the text of that job title, into a series of numbers. And we use what's called a vectorizer to do that. So this is actually separate work that we've already done where we've taken a database of, I think this was around 10,000 different job postings and looked through that whole list and essentially converted all of those job postings into categorized roles. And by doing that, we actually create this own custom vectorizer model that we can then use for any new job title. So we take this clean job title, we pass it through this function that then turns that job title into a series of numbers. And then the final part is we then match those numbers to estimate what categorization that job title is going to be. And that's where this kind of custom model that we've built comes in. So this is actually similar to how a large language model works with at a much simpler level. But the approach is very much the same. We kind of like take in an unknown, doing some processing work, and then coming up with a estimate of what we believe that thing is. And we found that actually going from the kind of original ChatGPT based classification to this approach, we've gone from about 80% accuracy to around 95%. So that approach seems to work pretty well. The third step, where we actually have found that the GPT model works well still, is actually using prompt engineering to take a job posting and actually look through the entire listing to predict the location that that job is based in. So the challenge here is that you could have locations for different company headquarters. Maybe the role is based in a certain area. Maybe you're reporting into an office in a certain region, but we want to know if the role is remote or not. And then if it's not remote, where is the actual job located more so than the company? And GPT is really good for this because it can actually infer meaning and understands the language used much better than any simple model that we could train. So we built this model, essentially uses this prompt, and it takes a list of cities based on where we've actually focused the job postings that we're actually looking at. And so there's about 10 different cities, and then there's a other category for the long tail of cities that are not really included in the core areas of job postings. And then we take the text of the job posting and we kind of send both of those things to GPT, and that returns back using this kind of second part of the function, returns back the predicted location based on that. And again, we found this to be very accurate, actually much more so than trying to infer it based on the range of different location names that could come up in a job posting, knowing that some don't include it actually in the listing, or sometimes it can be hard to find. So this approach has worked very well. And we essentially built that into a single script. And so we could automate this. I actually like to monitor it as it's running. But every 24 or 48 hours, I'll manually kick off this script. And what it will do is we'll take the jobs database, we'll run it through the entire database through the script of active job postings only. And then we get this kind of output, which is a series of kind of, these are the companies that we've checked, and these are the currently active roles or inactive roles. So we can see in real time how many roles it's removing. What we don't want to do is have some kind of bug that then deletes our whole jobs database, which is one of the reasons why I want to keep that process manual, at least for now. And then we kind of cycle that back in, and it updates every job in the job database so that we always have this kind of like lifetime of no more than 48 hours on how live a posting is. Given that postings generally stay up for a month or more, this kind of 24 to 48 hours is, I think, optimal for a good user experience without having to kind of like overload the function calling on our end. So that seems to work pretty well. We've actually had some huge benefits. Obviously, there's the cost saving because this doesn't require anyone to actually manually go through. We've improved the user experience using AI, but overall, really, it's just meant that the kind of quality of the platform is so much higher because we can be assured that even if we're doing everything right, what we really don't want to do is recommend a job to an end user that's actually not going to be live. So that was pretty much it. I hope that was helpful. I realized I went a little technical on some of the areas, but hopefully kept it high enough level so that you could understand it. If you are interested in seeing more deep dives like this, please drop in the comments or comment on one of the posts on LinkedIn, and I really enjoy doing these kind of things because this is an area that I've been learning as I've been going, and it's very exciting. But otherwise, please make sure you subscribe to the channel. The subscribe link's going to come up right now. And if you want to see more work that we've been doing behind the scenes, or some of the recommendations for more talent operations or AI and HR, you'll see one of the videos pop up here. So take care, and we'll be back soon.